Petrophysics is the study of physical and chemical rock properties and their interactions with fluids.
Petrophysical property determination. Petrophysical analysis can be used for the following: lithology determination, net pay determination, porosity determination, fluid contacts identification, water saturation determination, permeability determination.
There are four types of conventional petrophysical properties: lithology, porosity, water saturation, and permeability. Lithology, a description of the rock's physical characteristics such as grain size, composition, and texture. Porosity, the percentage of a given volume of rock that is pore space and can therefore contain fluids. Water saturation, the fraction of the pore space occupied by water. And permeability, the quantity of fluid, usually hydrocarbon, that can flow through a rock as a function of time and pressure related to how interconnected the pore space are.
Method of analysis. Coring and core analysis is a direct measurement of petrophysical properties. In the petroleum industry, rock samples are retrieved from subsurface and measured by core labs of oil company or some commercial core measurement service companies. This process is time-consuming and expensive, thus cannot be applied to all the wells drilled in the field. Well logging is used as a relatively inexpensive method to obtain petrophysical properties downhole. Measurement tools are conveyed downhole using either wireline or logging while drilling methods.
Development petrophysics. Development petrophysics emphasizes the integration of core data with log data, the adjustment of core data when required to reservoir conditions, and the calibration and regression line fitting of log data to core data. The goal of the calculation is to use all available data calibrated to the best standard to arrive at the most accurate quantitative values of the petrophysical parameters, like lithology, net pay, porosity, water saturation, and permeability.
Log analysis is used universally and is generally successful in the identification of oil and gas reservoirs and in their preliminary estimation of their volumes. However, log analysis augmented and calibrated with core and other data provides the most accurate quantification of oil and gas volumes present in a well and best represents the practice of petrophysics.
The description of petrophysical calculations are focused at the reservoir level, where there are several to hundreds of wells with logs and significant amounts of core data that need to be integrated to develop the most accurate overall values for the petrophysical parameters over the whole of the reservoir. The techniques discussed also apply to single well bores, but many of the complications are not a concern in single well evaluation.
There are three types of data acquisition methods: wireline, pipe conveyed logging, and the last one, logging while drilling.
Electrical wireline, vertical or low-angle wells, logging tools conveyed by electrical wireline, generally most advanced and highest quality logs.
The second one, pipe conveyed logging, highly deviated wells. Logging tools are lowered down the well by drill pipe with the tool connected at the end.
And the last one, logging while drilling. Sensors as a part of the drilling assembly, sending real-time signals through the drilling mud.
carbonate rocks. Clastic rocks consist primarily of silicate minerals and are classified on the basis of grain size and mineral composition. Carbonate rocks consist primarily of carbonate minerals, predominantly calcite and dolomite, and classified by grain size and texture.
Sedimentary rock types. There are 75% of clastic rocks like mudstone, siltstone and shale, 14% of carbonate rocks like limestone and dolomite, and 11% of sandstone and conglomerate clastic rocks.
This table illustrates grain size classification for clastic sediments. Clay have less than 0.004 mm of grain size. After that we have group of silts. It's very fine, fine, medium, coarse. It's range from 0.004 to 0.062. And the next group is range from 0.62 and 2. Here the groups of sands. It's very fine, fine, medium, coarse and very coarse. The next group is a granule, pebble, cobble and boulder. It's range from 2 to 4.096.
So this is the end of our presentation. Thank you for attention.